This video is going to go over page 10 notes in your packet. It's over lesson 4, solving quadratics by finding square roots. And I'm just going to do a few of these examples just so you have them. So basically, when you have a quadratic that is missing the b term. So for instance, on example 1a here, see how we just have 3x squared? We don't have another x term with just an x in it. When that happens, you are going to solve using inverse operations. So basically, you're just asking yourself, how do I get x by itself? So for instance, on 1a, I'm just going to subtract 5. I have 3x squared equals 36. And I think, well, I need to get rid of this 3, so I'm going to divide by 3. So I have x squared equals 12. And I'm like, well, all that I need to do to get rid of the x, or to get rid of that, get x by itself is to get rid of that squared. Well, how do I do that? Well, remember, the inverse of squaring is square rooting. So we square root both sides. So we have x equals plus or minus. Anytime you use a square root to solve, you have to use a plus or minus. Now, I need to simplify the square root of 12. So how do I do that? Well, I look for the perfect square that goes into 12, like 4. So 4 times 3. Square root of 4 is 2. So my answer is plus or minus 2 root 3. And you could figure out that decimal in your calculator, and then your graph would be crossing at both of those points. Okay, so let's do another one. So example B. I need to get x squared by itself. I'm going to subtract 15, which gives me negative 80. Divide by 2. So x squared equals negative 40. And now I'm going to square root. So we have x equals plus or minus. 4 goes into 40, but since it's negative 40, I'm going to do negative 4 times 10. And the square root of negative 4 is 2i. Remember, anytime you have a negative underneath the square root, that brings out the I. Okay, since we have 2i, that means we don't have any real solutions, which means our graph would not be crossing the x-axis. Okay, so let's look at, we're going to skip C. You're going to do it pretty much the same way. If you can simplify the square roots, always simplify. If it was like square root of 36, you would just put plus or minus 6, so on and so forth. Okay, so then take a look at example 3. So I'm trying to get x by itself. And remember, we're doing PEMDAS backwards. I'm going to write that up here. PEMDAS. And to solve an equation, we actually do it backwards. So we undo any addition, subtraction, then multiplication, division, then exponents, then parentheses. So this parenthesis right here is going to be the last thing that I undo. So there are no addition, subtractions except for within the parentheses. So I'm going to skip that. There is a multiplication. This 3 is being multiplied. I'm going to undo that by dividing both sides by 3. So x minus 2 squared equals 9. Undo the squared, I square root. So I have x minus 2 equals plus or minus 3. That squared was undone, so I was just left with what was in the parentheses, that x minus 2. Square root of 9 is 3, that's why I just brought it out. We still have to use that plus or minus when we're using a square root to solve. Now x is not by itself, so I have to add 2 to both sides. So I'm looking at 2 plus or minus 3. Now these are both integers. I can add these together. 2 plus 3 is 5. 2 minus 3 is negative 1. Be careful when you do that. It's not plus or minus 5, plus or minus 3. And so we have to do 2 plus 3, 2 minus 3. Okay, let's look at another one. Let's look at B. So here, I have this thing being divided that I need to undo. So I'm going to multiply both sides by 5. And that cancels this out. So I have x plus 3 squared equals 35. Now I need to undo that squared, so I'm going to square root both sides. So we're left with just x plus 3 equals plus or minus square root of 35. To get x by itself, I have to undo that plus 3. The opposite of adding is subtracting, so I'm going to subtract 3. So I have negative 3 plus or minus root 35. Now, I can't add negative 3 and root 35. They're not like terms. So I can either leave it like this, or I can see if I can simplify that root 35, which I can't because there's no perfect square that goes into 35. So this is my final answer. Okay, you can check out the answer key for lesson 4 practice on the website. So please do so, and good luck, and let me know if you have any questions.